You're watching a Hanford Communities issue briefing, highlighting important environmental cleanup issues at the U.S. Department of Energy's Hanford Site in southeastern Washington, issues affecting citizens of the Pacific Northwest and the nation. The Hanford Communities organization was established in 1994 and is comprised of the communities surrounding the Hanford Site, forming one voice to advise the Department of Energy on important transition and cleanup issues. The Hanford Site is a U.S. Department of Energy-owned, contractor-operated facility located in the southeastern portion of Washington State near Richland. The 586 square mile site supports programs in waste management, environmental restoration, and science and technology. For more than 40 years, Hanford nuclear reactors and processing facilities were used to produce plutonium for America's nuclear defense program. Liquid waste generated by the production mission was released into ponds, cribs, trenches, drains, wells, and basins, in addition to some spills and leaks to the soil. During this time, scientists estimate that about 475 billion gallons of contaminated liquids were released into the ground at the Hanford Site. Some contaminants carried by these liquids remain in the vadose zone, the area between the top of the water table and the surface of the ground. Others have reached the groundwater under the site, creating several large contamination plumes. At Hanford, the groundwater typically moves towards the Columbia River. Crews are able to monitor what contaminants are in the water and where the groundwater is moving, using thousands of wells drilled throughout the Hanford Site. These wells provide critical information to scientists, who can then determine the most effective ways to deal with the contamination. The United States Department of Energy and its primary contractor for monitoring and remediation of Hanford groundwater, CH2M Hill, are addressing one of the most complex and challenging environmental projects in history. The overall strategy is based on a holistic approach towards cleanup that integrates facility decommissioning and demolition, removal of radioactive sources from the soil column, and groundwater remediation.
Hi, I'm Jean McKenna, and welcome to another Hanford Communities issue briefing. Today we're going to talk about ongoing efforts to remediate groundwater contamination beneath the Hanford Site. Our panelists include Matt McCormick, Assistant Manager for the Central Plateau, Department of Energy, Richland Operations Office; Diane Foss, Vice President of the Soil and Groundwater Remediation Project, CH2M Hill Plateau Remediation Company; Zelma Main Jackson, Hydrologist, Washington Department of Ecology; Lynn Albin, Radiation Health Physicist, Washington Department of Health; and Dennis Falk, Manager of the Hanford Project Office, Environmental Protection Agency. In our audience today are elected officials, staff of the Hanford Communities, and members of the Hanford Advisory Board.
Good morning. My name is Matt McCormick with the Richland Operations Office. Hanford cleanup is a huge undertaking, both in terms of cost and time. Today we're going to talk about the cleanup of Hanford groundwater, both the protection of groundwater and the cleanup of groundwater at the Hanford Site. Groundwater is not only a valuable resource, but it's the main connection to the environment from the Hanford Site. This is because groundwater flows from the Hanford Site into the Columbia River. And of course, an important objective of cleanup of the Hanford Site is to protect the Columbia River. Groundwater underlines most of the Hanford Site, and as a result of plutonium production operations in the past, groundwater was contaminated. And this groundwater contamination was due to intentional discharges from the plutonium production facilities that were operated from the mid-1940s to the early 1990s. Along the Columbia River, groundwater was contaminated from the operation of 9 large production reactors that were adjacent to the river and the fabrication of fuel for these reactors in the southern portion of the Hanford Site called the 300 area. Groundwater on the central portion of the site was contaminated through the operation of 5 large chemical processing facilities that separated plutonium from the spent fuel. These facilities discharge huge amounts of liquid contaminated water into the soil and subsequently contaminated groundwater. The main objective for groundwater cleanup is to restore groundwater to its highest beneficial use, which is normally drinking water standards. These goals that I'm talking about are also rooted in the laws, environmental cleanup laws and regulations that we're required to follow. So we want to clean up groundwater to its beneficial use, which is normally drinking water standards. We also want to stop contaminated groundwater, especially key contaminants, from entering the river. The key contaminants along the river are chromium, strontium-90, and uranium. For the central portion of the site, we want to contain key contaminants to the central portion of the site. And these key contaminants for the central plateau are uranium, carbon tetrachloride, and technetium-99. And then, of course, a major component of cleanup is to protect groundwater from future contamination. So as we implement cleanup measures both along the river and in the central plateau, we want to make sure groundwater doesn't get contaminated in the future. We also have some specific goals with time frames for cleaning up groundwater. These are, the main one for along the river is to stop chromium from entering the river by 2012. Also along the river, we want to stop the strontium-90 plume, which is a small plume in the end reactor area, from entering the river by 2016. The other goal we have along the river is to implement cleanup of the uranium plume in the 300 area by 2015 and clean up that plume to meet drinking water standards as soon as we can. Moving to the central plateau, we have a goal to contain contamination on the central plateau, those key contaminants I mentioned, carbon tetrachloride, uranium, and technetium-99, and also implement groundwater remedies to clean up that groundwater to meet drinking water standards for the most part. So those are our main goals. Diane Foss is going to talk about some actions we've taken or are taking to meet those goals and objectives.
Thank you, Matt. As Matt said, I am Diane Foss. I work for CH2M Hill Plateau Remediation Company, and I'm the Vice President of the Soil and Groundwater Remediation Project. I think it's easiest to think about the groundwater program in two parts, the river corridor and the central plateau. And that's primarily because not only are the contaminants different, but the groundwater is different as well. It's a little bit closer to the surface along the river, and there are river influences on the hydrology there. And the central plateau is quite a bit deeper. I'll start with the river corridor. We do currently have 5 pump and treats operating along the river. 2 of those are in the D&H reactor area, and 3 of those are in the K area. Pump and treat essentially extracts groundwater from the ground. It goes through a series of tanks, and there's resin in some of those tanks. The resin itself takes the contaminant, which happens to be hexavalent chrome, and it changes the hexavalent chrome to trivalent chrome, which is a lot less toxic. And then that chrome gets stuck on the resin itself, and the water goes into a tank. We sample that tank to make sure it's ready to return to the environment, and then we do that. These are really interim systems that we're operating right now, and as Matt said, we do have some new hard targets to stop the chrome from entering the river by 2012. In order to do that, we are constructing 2 new pump and treats. Those 2 new pump and treats are going to be out in the D&H area. The first one is DX, and actually the construction is going to be complete in June of this year, and that is a Recovery Act project. We've designed and constructed that pump and treat in the first year of the Recovery Act. We wouldn't have been able to do that without those funds. The second one is going to be called HX, and they're actually going to work together. One of the things I think people don't think about when they think about pump and treats is how we get the water from the wells to the pump and treats themselves. And so with those 2 systems, there'll be about 100 wells and 100 miles of pipe. You look out in that area, it's a big geographic area, and so we really do have to bring the water, in some cases, from a very long way. In addition to those 5 pump and treats, we have 2 passive barriers on the river corridor. The first one is the in situ redox manipulation barrier. That's actually just iron filings in the ground, and what happens is the water, as it moves towards the river, it again sort of strips the ions off the hexavalent chrome and turns it into trivalent chrome, which is a lot less toxic. The other barrier is also kind of a chemistry test. It's called the apatite barrier. It's out at the 100N area, and it is to remediate strontium-90. So that's the only remediation system we have on the river that is treating something other than the hexavalent chrome. The way the apatite barrier works, we actually inject calcium and phosphate into the ground. That encourages the development of a mineral called apatite. And as the water passes through on its way to the river, the strontium-90 actually replaces an element in the apatite and gets stuck into the soil matrix. So it's a kind of a low-tech system. You can't see it. You know, there's just a series of wells in the ground, but yet it's truly effective remediation technology. On the Central Plateau, I'll just move to that one, we do have one pump and treat and what's called a soil vapor extraction unit. Both of those units remove carbon tetrachloride. We are, again, with the help of Recovery Act money, building a new pump and treat. This pump and treat will be unique to the other pump and treats in that it'll treat more than one contaminant. So the focus of this pump and treat will not only be the carbon tetrachloride, but uranium and technetium-99. This system will be much larger than the rest of our systems. Our systems right now really range from 300 gallons per minute to about 600 gallons per minute. This one will go all the way up to 2,500 gallons per minute, and it will be focused on treating a larger area. Not only is it going to be focused on one particular area, but we've built some flexibility into the system to be able to treat things as they emerge, because it can treat all of these different contaminants. The groundwater program is pretty exciting right now. It is due to the additional funds we've received and these new targets that we have. And just for kind of a perspective, you know, right now we treat about 80 million gallons of groundwater per month. By the end of 2012, that's going to more than double. It'll be over 180 million gallons per month. And I think the easiest way to think about that, because it seems like a lot of water, it is a lot of water. And so if you think of your average backyard swimming pool, that's like filling that swimming pool in 3 minutes.
Good morning. My name is Zelma Main Jackson, and I'm a hydrogeologist with Washington State Department of Ecology at the Nuke Waste Program located at Hanford. The role of the Washington State Department of Ecology is twofold. One is being a part of the tri-party agreement, which includes the Department of Energy, EPA, and ourselves. We ensure the legal standards for cleanup at Hanford, which proceeds on to, for groundwater, which proceeds to the Columbia River. It's vital for the people of Washington to feel secure about the activities at Hanford, and Washington State Department of Ecology is in the front runner of trying to ensure the people of Washington that occurs. One of the ways that we do that is through the Washington State Model Toxic Control Act, which require cleanup levels to be based on the highest beneficial use of groundwater. The second is the protection of the aquifers from pollution or degradation, which is a very important concern for the people of the state of Washington. It is by all means the intent of both the legislature, local governments, the tribal nations, and other interested parties to ensure that water resources of the state are wisely used. We have been a part of ensuring that all three of these initiatives happen at Hanford for the last almost 20 years.
I'm Lynn Albin, and I'm glad to be here to talk about health issues related to radiation. I work for the Washington State Department of Health Office of Radiation Protection, and our job is to protect the public from exposure to radiation. We regulate the uses and emissions of radioactive materials. We inspect facilities to make sure that they comply to these rules, and we monitor the environment on and around facilities that have a potential to emit radiation. The others have talked about their work on cleanup of groundwater and preventing contaminated groundwater from reaching the Columbia River, and I'm going to tell you about the work done by the Department of Health to monitor the environment around Hanford and to assure that the public's health is protected. At Hanford, we protect the public through our independent oversight of the Department of Energy activities. One of the primary tools that we use is environmental monitoring. Each year we collect over 700 samples of air and river water, groundwater, fish, game, food crops, vegetation, soil, and sediment, and we analyze these samples for radioactive contaminants. Okay, we also measure radiation levels along the Columbia River and other places around the Hanford site. And these samples are analyzed by our laboratory in Shoreline, Washington. Environmental monitoring is important because it allows us to use actual measurements to make public health decisions. For instance, contaminated groundwater can migrate to the Columbia River, and hence we then sample the Columbia River at the Richland Water Treatment Plant for contaminants. And our analysis show that after standard treatment for water, the water meets all drinking water standards set by the EPA. Our tests also show that food irrigated from Columbia River water and fish caught in the river are safe to eat. We also measure radioactivity at specific locations where contaminated groundwater is entering the Columbia River, and we find that the contaminants quickly disperse in the river. And after many, many years of sampling and testing, we find that the Columbia River is a safe source of water for irrigation, for recreation, and after standard water treatment for drinking water. Your turn.
Good morning. I'm Dennis Falk with the U.S. Environmental Protection Agency. And what I want to do is just highlight a few other points that haven't been made. And I think the first thing I want to do is go back in history. Again, we've actually been at this cleanup for now 20 years. The Tri-Party Agreement celebrated its 20-year anniversary just last year. And we've made a lot of progress. As Matt said, the cleanup of Hanford is massive. It is by far one of the most contaminated sites in the nation, and it just has a lot of contaminated groundwater. There's more contaminated groundwater at Hanford, I believe, than probably anywhere else in the nation. Back in the early 90s, we went aggressively after our most urgent risk in groundwater. We set up systems to take care of the strontium, the chromium, and the carbon tetrachloride. Those systems were put in place to help contain those contaminants, and they've been operating relatively effective over the years. We then, in my opinion, lost a little bit of focus. Again, groundwater, or Hanford in itself, is a massive cleanup. And over a 4 or 5 year period, those pump and treats were operating. We went to focus on other things, particularly removal of soils along the river. It was about 5 or 6 years ago, through a public forum, something we call State of the Site, the public started asking a lot of questions about, hey, what are you doing with the groundwater currently? And it made us go back and reanalyze, and it was like, it's time to refocus on that groundwater. And based on that, we did. And so over the last 5 to 6 years, we made tremendous progress in developing new technologies, expanding our systems. And it was just last year we put into place, into the Tri-Party Agreement, these aggressive goals that were talked about by Matt and Diane, to actually stop chromium from flowing into the river by 2012. That is an extremely aggressive goal, but I think DOE and their contractors are well on the way to meeting that. The other interesting thing from my perspective too is we think of Hanford in the scheme of radionuclides, and we always talk about the radioactive component of the cleanup. But in fact, the chemical part of the equation has actually been more problematic for us. Chromium was used in the reactors, sodium dichromate, as a corrosion inhibitor that was directly discharged out into the soil column. And that is actually one of probably our most problematic contaminant at this point. It's very toxic to aquatic life. And so that's why we're really focusing very seriously on the chromium. The other contaminant, the carbon tetrachloride, which is up on the Central Plateau, it was used in the processing at the plutonium finishing plant. Hundreds of thousands of gallons of carbon tetrachloride was discharged out into the soil. We have up to 1 million pounds is expected that could still be available for us to have to clean up. And so again, it's not a radionuclide, but it is probably one of our most problematic cleanups. The department has been very aggressive on that. Again, we've just setting up a pump and treat system that will be treating at over 2,500 gallons a minute. And this may not sound aggressive to you, but the goal of this cleanup is to actually take out 95% of this carbon tetrachloride within the next 25 years. And again, in the scheme of cleanup, that is a very, very aggressive program. So again, I'm glad to be here and look forward to any questions you might have.
Hi, I'm Ed Ravel, Chairman of Hanford Communities Governing Board. It was very encouraging to hear that the Recovery Act funding has helped a lot, and it sounds like it has helped where it may help you exceed or maybe meet or exceed the tri-party agreement milestones. Could you give a little more detail on that?
That's an excellent question, actually, about the Recovery Act and how that's going to help us meet our goals. As Dennis had said in his opening, the targets that the tri-parties have signed up to are very aggressive to stop the chrome from entering the river by 2012. And without the Recovery Act funding, we would have had really no chance at meeting those targets because so much still needs to be done in those areas. Exceed the goals? Probably not, because it doesn't take very much hexavalent chrome to create a large plume, and so because geographically we are spread out, I mean, we're going to have to do everything we can to get to that 2012 milestone.
I actually would like to elaborate on that just a little bit, Ed. Quite honestly, the Recovery Act money was very, very helpful in moving a lot of these cleanups forward, but quite honestly, the cleanup has been underfunded for the past few years. And so what really the Recovery Act did was really made us whole over these next couple of years. And we're hopeful that in 2012, again, we'll have solid budgets that can continue this work on.
Hi, I'm Pam Larson from the Hanford Communities. Can you tell us how long it takes contamination in the Central Plateau to move from the center of the Hanford Site to the Columbia River?
It really depends on where you're at in the Central Plateau. If you're in the western portion of the Central Plateau, like where the plutonium finishing plant is located or the environmental restoration disposal facility is located, it takes decades for contamination to move from that area to the river, and contamination generally flows to the east or southeast towards like the 300 area. In the eastern part of the Central Plateau, which is closer to the Columbia River, there's a shorter travel time because the distance is shorter, and then also groundwater moves a little bit faster in that area. So it takes 10 to 20 years in that area versus 50 years or more in the western part of the Central Plateau. When this site was operating and plutonium was being produced, there was huge amounts of water being discharged into the soil, and that accelerated some of the movement of contaminants during operations from contaminants from the Central Plateau to the river. Those discharges have stopped, and those stopped in the early 1990s, so that hydraulic pressure or force is no longer there, so groundwater contaminants have greatly slowed down in terms of movement.
And I'd like to add on to that answer. As a hydrologist, keep in mind that what you see on the surface of the earth is totally different from what is beneath the earth. There may be, and we don't have the answers or a looking glass to actually see the subsurface. What we have is thousands of wells throughout the Hanford complex that gives us an indication of the speed and how fast groundwater and the contaminants move within it. Keep in mind that there may be instances in the subsurface where contaminant is hung up because it's retarded by clay or with very compact soils. So the time frame varies considerably as groundwater and contaminants move across the site to the Columbia River.
One of the things you talked about was the importance of new technologies. And it sounded like in the early days maybe the technologies were not very effective, but over time you've developed technologies that are a lot better. And my assumption is you will still need new technologies to help you complete the project. Can you talk for a few minutes about what the dependence is on these new technologies and how they play in?
That's a good question. We have made a lot of strides in technology on the groundwater front. We've developed several technologies, we call them in situ type technologies, where we can actually inject chemicals that will change the form of the contaminant. We can put it on the surface, let it percolate down. And again, when you can actually treat things in place, that tends to be a better technology, usually cheaper. And so we've come a long ways that way, particularly on the chromium contamination. The place where we really need to focus over the next few years is actually developing technologies to deal with the contamination in the deep soils. We do not have very many tools in our toolbox to deal with that. And so that's really going to be the push over the next several years, because ultimately, to be protective of groundwater, we've got to deal with that contamination deep within the surface.
What happens to the contamination once you've removed it from the groundwater?
Many of the remediation technologies that we do result in some additional waste products, and some of those go into the local disposal facility at Hanford, the ERTA facility. But the pump and treats along the river, the resin that I talked about in the opening, the current resin that we use, we actually can send that off-site to be regenerated. So we send that off-site, they regenerate, so they strip off the trivalent chrome and they send it back to us to reuse. These new systems that we're using actually are going to use a different kind of resin. And this resin is actually going to be disposable. And on the face of it, you might think that's not a very good environmental thing to have to use. But actually, this particular resin lasts 10 times longer than the current resin we use. We will be able to, once we're done with it, we'll solidify it and keep it on site. And we've done the math on this, and actually this kind of resin over the lifetime of the operation of the project is going to save over $20 million. And so it's essentially going to pay for the facility that we're building today.
We've heard a lot about the efforts of the Department of Energy to shrink the footprint of the Hanford site and the goal of doing that by 2015. So does that mean that groundwater will be cleaned up along the river, or is there going to be ongoing effort to pursue the plumes in that area?
When we talk about shrinking the active footprint of cleanup of the Hanford site, we're talking about completing implementation of cleanup remedies or actions along the river. So that means demolishing the excess facilities, digging up the contaminated soil and the solid waste that was buried next to the river, and then implementing groundwater remedies to meet the goals that we've talked about today in terms of stopping chromium from entering the river by 2012, and cleaning up the chromium contamination. We have another goal by 2020. So by 2015, we should have all the groundwater remedies in place to clean up groundwater, but some of those remedies will continue to operate after 2015, like pump and treat systems along the river to deal with chromium, or the apatite barrier for the strontium contamination in end reactors. So those remedies will be in place and working after 2015.
And Pam, maybe just one other thing. I talked about earlier the carbon tetrachloride plume. Again, the goal there is to have reduced the contamination by 95% within 25 years. So that's one of our more problematic cleanups on the groundwater. So that gives you kind of a time frame. You know, our expectation is a lot of these systems will have to operate next 20, 30, 40 years probably.
I'll just hit on the river corridor. We have done the modeling on the pump and treats on the river corridor, and our goal after 2012 from stopping the chrome from entering the river is to take the plumes to drinking water standards. And we currently project that'll happen around 2020, and that we'll need to operate the pump and treats for 5 additional years after that, and hopefully by 2025 we'll be able to shut those systems down.
To find out how you can become more involved in this important regional issue, or to have a Hanford community speaker talk to your organization, Contact the Hanford Communities at 509-942-7348 or by fax at 509-942-7379 or visit our website at www.ci.richland.wa.us.